Hi folks. In this video, we're going to talk about trend lines in data. So we're going to talk about how to create a trend line in Google Sheets and also different types of trend lines and why you would be looking for one. So I went back to the sample data we had for the range and the height, and this is the data that we had. So I want to make an important point here. I think it's fairly obvious if you think about the experiment that we did. You're rolling a ball down a ramp, you're letting it roll off a table. I think it's fairly obvious that most people would understand that if you started the marble up higher on the ramp, that it's going to land farther away from the table. That seems pretty obvious. So if that's all you're going to offer, then really you don't need this data. The whole purpose of collecting this data is so that we can be very specific about what type of relationship are we talking about? What mathematical quantitative relationship is present between the data? Otherwise, we're not really saying anything that wasn't obvious. So some of the typical types of relationships that you might talk about in a physics lab might be a linear relationship where y is proportional to x. So that means that as x grows by some factor, y grows by the same factor. If you double x, you double y. If you triple x, you triple y, etc. A polynomial, y is proportional to an integer power of x. So this could be x squared, x cubed, x to the fifth, etc. So, a quadratic relationship or a cubic relationship, that would be polynomial. In one case, you might have the x value doubles and the y value quadruples. That would be a quadratic relationship, which is polynomial. A power series is kind of like a polynomial, except when it's a non-integer power of x. A lot of times we use power series when we have like a square root function or something of that nature. And then there's an exponential, and a lot of times students will mix up exponentials and polynomials because on a graph a lot of times they look pretty similar. But in an exponential, the difference is that the x is in the exponent, not in the base. All right, in a polynomial, the x is in the base, not the exponent. So exponentials tend to grow, most times, tend to grow faster than polynomials do, but not always. So these are some common ones. There's obviously some others too. But we want to be able to tell what type of relationship are we looking at in data. So we'll use this data as an example. So let me show you how to do a trend line. We're going to click on the graph first. Okay, once we get to the graph, we can go to Edit Chart, and we want to go to Customize. The series option is where you're going to find options for trend lines. So we're going to go here, and you scroll down, you will notice a box to check for trend line. So I'm going to check the box, and then some other stuff's going to open up. Now you'll notice by default it automatically does a straight line, and you have this linear option. Okay. Before you do any sort of before you decide on any sort of trend line, you want to make sure that you choose this label option that says use equation. It might have none. You want to use equation. Always show what the function is that's the data is showing. So you want to click that. And then you also want to check this box for show r squared. The r squared is the correlation. So it tells us how well does this function actually, how close does it come to the actual data points. Okay, you'll see this number here, r squared equals 0.983. The closer that number is to 1, the closer that function fits your data set. So it's going to give us a good idea of how that works. All right, so we can choose from some different options here. I didn't talk about logarithmic, but that's another one that's in there. Okay, so if I try, for example, an exponential fit in this data, you'll notice physically you can see it doesn't fit quite as well, and the r squared actually shows that as well. 0.939 is not as high, so it doesn't fit quite the same way. If I try a polynomial, get a really good fit. All right, 0.999. if I try a power series, I get a perfect fit. R squared equals 1 in this case. So you can play around with the different options to see which trend best fits your data, and then you can talk about that in a conclusion to your lab report or something like that. I want to give you a word of caution, though. This is an important one to think about, especially in honors and AP. Just because the R squared is the highest number does not necessarily mean that that is the function that represents the data. Because remember, your data is not perfect to begin with. This is data that you measured, okay, or I measured if it's a virtual lab. But the point is, it's not perfect. So you might have, for example, if I go back to that polynomial, this polynomial data fits this function, fits this data, I should say, really, really well. 0.99, that's almost a perfect fit. But as a scientist and as a person who understands math, I know for a fact that it can't possibly be a polynomial. Take a look at this function. 6.13 plus 0.856x plus negative 0.798 x squared. Here it is. So think about what that looks like. It's a parabola, right? We got an x squared, an x, and a constant. It's a parabola that's upside down. If you can imagine, this graph probably goes up, and then the trend line peaks somewhere, and then it comes back down. But think about what we did, range versus height, as an experiment. There's no way that that data comes back down. If you kept going up in height on the ramp, it's not going to suddenly start going less and less far. That makes no sense. So even though a polynomial fits the data really well, it doesn't make physical sense to be a polynomial function. If we go to a power series, you'll notice that it's 4.47 x to the 0.5. Think about x to the 0.5, x to the half. That's a square root function. So that's going to go up and keep going up. It's never going to come back down. That makes a lot more sense than the polynomial function. Now in this case, the r squared fit was better. But you might have a situation where the r squared might actually be a little bit lower, but it's the right fit. So you have to really think about what makes physical sense sometimes and use that. Okay, so just as a quick review again on how to do it, you're going to click on the edit chart. I already have that up. You go to series on the customize tab. You want to make sure that you choose trend line, check the box, and then you can play with the different options here. Make sure though that you always show the equation and show the r squared value on the chart. So you're going to need to do this for your data for the range of a marble lab, create the graphs, and find which function fit you think fits best.